Ev- Hello there everyone and welcome to my first vlog. I will react to some I will react now some of the universe. I will react three of them. I will watch the 10 facts about the sun, the black holes and the Neptune. Okay, let's start with the black holes. Black holes. Come. Oh, let's watch this.
Most people believe that the first person to develop the idea of black holes was Albert Einstein. While it's true that the Austrian genius did revive the theory in 1916, it was actually John Mitchell who first came up with the concept of black holes in 1783. He wondered how the movement of light particles is impacted by the gravitational pull of the star they are escaping, and what would happen to these particles if the gravitational pull was so strong that light could not escape. A wormhole, also known as an Einstein-Rosen bridge, is a theoretical opening in space-time, enabling a shortcut from one point in the universe to another. From the outside, wormholes may exhibit many of the characteristics usually associated with a black hole, meaning the two can be virtually impossible to tell apart. Black holes hold a massive amount of mass in an incredibly small space. As an example, to make a black hole with the mass of Earth, the entire planet would need to be squashed down to a space of 9 millimeters across. Some supermassive black holes in the center of the galaxies could have a mass of 10 to 30 million times that of our sun. When a black hole pulls something in, it speeds up. The event horizon supercharges the velocity of these particles close to the speed of light. It's theorized that when stuff falls through the center of the event horizon, there is a gurgling sound. This sound is the energy of motion being converted into sound waves. Not only do black holes suck up everything that gets near them, they also eject matter. When all of the vacuumed up mass gets crushed together so hard that space between the individual components of the atoms is compressed, it is broken down into subatomic particles that can stream away. These particles are released in jets, which propel out of the black hole due to intense magnetic field lines that can cross the event horizon. According to some scientists, it's theorized that the number of stars in the universe is limited by black holes. The particle jets emitted by black holes expand into bubbles that ripple through gas cloud regions where stars are formed. New stars come about when these clouds cool, but the jets can heat up the gas clouds and prevent stars from forming. Theoretically, it's not just stars that can become black holes. According to the principle of the Schwarzschild radius, if you collapse the entire mass of the object into a single point, the density would be so great that not even light could escape, thus creating a black hole. Of course, there's no known way to compress anything to such a finite point. When anything, even light, passes close to a black hole, it will be pulled in by its gravity. If anything else acting on the object is stronger than the black hole's gravity, then it can escape the pull until it reaches the event horizon. The only way to escape from this point is for an object to travel faster than the speed of light, which is impossible. In astrophysics, spaghettification is the vertical stretching and horizontal compression of objects into long, thin shapes, rather like spaghetti, in a very strong, non-homogeneous gravitational field. It is caused by extreme tidal forces. In the most extreme cases, near black holes, the stretching is so powerful that no object can withstand it, no matter how strong its components are. Sounds pretty cool if you ask me. If we could somehow watch a clock getting sucked into a black hole, its hands would appear to slow down as it approached the event horizon, and eventually it would seem to freeze altogether. The freeze in time is due to gravitational time dilation, which is explained by Einstein's theory of relativity. The gravity of a black hole is so strong it can slow down time, but from the clock's perspective, it is still functioning normally. Anyone who's watched Interstellar will get the idea. The singularity at the center of a black hole may eventually become an infinitely small point in space, containing infinite mass. Here, the gravitational force is so strong that the space-time surrounding the singularity is bent to an infinitive curvature. It's hard to conceive of something that has no size yet infinite density, and it's at this point where all the laws of physics that govern the universe completely break down. I really want to see how it's like inside a black hole now, even though I'd be stretched to the point where all my living cells would painfully get ripped apart. You only live once, right?
Wow. Okay guys, hope you like this video, and I will see you next time. Goodbye, bye.